think we should start our workshop. Thank you everyone for coming. Nice to see you, all of you in the chat, and I hope you see my presentation. Hi. Okay, today I want to teach you a little about DLT. So this workshop about DLT fundamentals, we are going to learn about high-level DLT terms and functionality. And today I want to present a small DLT introduction of this presentation. And we want to discuss what is DLT, what is DLT, why DLT, and how DLT work. Let me introduce myself. My name is Alona. I'm a data scientist / DevRel at DLT Hub. Today, I'll share with you everything I know about DLT. First, a small introduction into DLT. So DLT, it's an open source Python library for data loading from source to destination. I talked earlier a little about DLT. How to change it? Okay. So let's start from the beginning. Yeah, let's talk about what is data engineering at all, and how DLT helps data engineers. Data engineers, they are the architects of the data world, and they build the pipelines that move and transform raw data into something useful. They extract data, transform it, and load it into storage systems, and turning raw information into something ready for analysis. In other words, they mostly write ETL pipelines. What is ETL pipeline? I believe that everybody knows what ETL pipeline is, but let me refresh your memory. ETL pipeline, it's a pipeline when you take your raw data from the source. It could be anything, database, API, files. You transform this data and move it to warehouse, to database, cloud warehouse, data lakes, and any place you want. But also I mentioned ELT, yeah? And what is the difference between ELT and ETL? So ETL, it's a classic hero. ETL stands for extract, transform, load, and it fits better if you like having data at the end very well structured, clean, and ready for analysis. ELT stands for extract, load, transform. So you first extract your data, or load your raw data into a warehouse, and after that you transform it. It's more fast and flexible, but sometimes a bit messy. And so the question is, what is better? You should spend a lot of time to preparing your data. So ETL pipelines, they take a lot of time to prepare. ELT is faster, but might be messy. And DLT helps you with this question a little. So DLT transform your data before you load it to a warehouse, but it takes the bigger part, the most complex part of transforming, and load structured and clean data to your warehouse, and after that you can have more complex transformations. Okay, so what's data engineering at all? Yeah, as a citation of data engineer on Reddit, I'm a plumber. I pipe data from one place to the other and make sure it's clean for the business to use. So that's quite easy. Yeah, what the engineers doing, moving their data and prepare it for using. Yeah, in other words, data scientists need clean data, structured data in a scalable infrastructure with robust pipeline, and data engineers trying to make them happy. But there is a plot twist. Data scientists deal with data engineering tasks too. So it means in reality it's unavoidable, and every data job is a data engineering job. But the thing is, not everybody is a data engineer, and or is simply not paid enough to be one at the same time. Uh, and every data engineer has to be ready to solve problems, whether they arise from new business requirements or pipeline breaking. So, every data engineer faced with unstructured and nested data, and you need to somehow to unnest it, you need to flat it and create a schema. Another problem is schema evolution. It's always your data always changing, your data types changing, new columns or keys appears, and you need to constantly update your schema. And currently, people doing it manually or using the custom Python scripts. Another problems and some data contracts. Data contracts define and enforce the functionality, manageability, and reliability of data, like enforcing rules on schema changes. So it helps you control your schema, and DLT can help you with it. Another problem, too many ad hoc data sources. We talked with a lot of people recently, with a lot of data engineers and data analysts, and asked them, how they create their data sources. And every time we can hear that, oh yeah, I have a bunch of really bad codes, Python scripts, and I want to replace it with something more reliable. Another problems is incremental loading. Nobody wants to reload their data every time, again, especially when they have a huge of millions of rows, billions of rows. In this case, it would be smarter load only new data, only and merge it with the old one. And another problem is it's a performance issues. When you're working with the big data streaming and managing large amounts of data, it can take a really long time. The solution, DLT, data load tool. It's open source. It integrates and scales well. It's Pythonic. So, what is DLT? It's an open source Python library for data teams loading in unexpected places. And a little bit about DLT history. Many of you knows Adrian, our co-founder. He was working as a data engineer freelancer for 10 years or something. And he was building data pipelines again and again for every company. And once he just realized why people still didn't create any reusable code, any library. And that's how the idea was born. Okay, let's discuss a little bit deeper what DLT is. I love this diagram because it shows you the main idea. So DLT, it's open source Python library again. It works in 3 steps. It extracts data, it normalizes data, and load data from sources to destinations. That's quite easy idea. Uh, Also, DLT is the install and setup. You just install it with pip install. It's easy to use. The learning curve is shallow. Interface is declarative. It's Pythonic. You don't have to learn new frameworks or programming languages. So it's not a framework. It's not a platform. It's not a new language. It's just old good Python. Also, it's just a library. So it means it runs anywhere Python runs. Let's talk a bit about data engineering best practices. So DLT contains all data engineering best practices. Anyone who ever worked with Python can create the pipeline on the senior level. For example, DLT handles schema evolution. With DLT, schema evolution is handled automatically. When modification occurs in the source data schema, DLT detects these changes and updates the schema accordingly. Also, DLT has data contracts. You can use data contracts modes to tell DLT how to apply contracts for a particular entity. You can evolve, you can freeze it by value or by row. Also, it handles incremental loading. It's just a few lines of code and your data loading incrementally. If you don't know what means incremental loading, so it's crucial concept in data pipelines that involves loading only new or changed data instead of reloading the entire dataset. And performance management. DLT provides several mechanisms and configuration options to manage performance and scale up pipelines, like parallel execution, thread pools and async execution, memory buffers, and scalability through iterators and chunking. Also, DLT is database agnostic, so you can load your data to different destinations without changing anything. So you just change the name of destination, and your load can be loaded, and your data can be loaded in different destinations in a few seconds. Also, DLT trying to make the process of creating custom sources as easy as possible. For example, using high-level declarative REST API source or low-level REST API client. So it handles the biggest part of creating sources, like pagination, authentication, and so on. Or you can also use pure Python with requests. Also, DLT has pre-built verified sources and destinations. We have like 30 plus existing well-tested sources, such as Postgres, SQL databases, REST API, Google Sheets, Zendesk, Stripe, Notion, and many, many more. We have many destinations like DuckDB, Postgres, data tables, BigQuery, Snowflake, and so on. Also, DLT support reverse ETL. You can create your own custom destinations. Also, DLT has many integrations with other popular tools like dbt, Airflow, Streamlit, and you can easily run it in Google Colab. You can run it on AWS, Lambda function, or Airflow, or anywhere Python runs. So, why DLT? From junior's perspective, why DLT is a good choice? It's open source. It integrates and scales well. It's Pythonic. What does it mean for juniors? It means we have really great community. It saves time for other things. And it has smooth learning curve. And the same points from a senior perspective. Open source means cost effective, integrates and scales well, means no excuses from juniors. It's Pythonic. It means also no need to reinvent the wheel. Yeah, that's right. And it's Pythonic, and it means works where Python runs. So that's why would you need DLT? In case you haven't been convinced yet, you can build data platforms. You can focus on other tasks rather than setting up and fixing your data pipeline. You can come in handy if your work includes data science or data analytics. That's low code, low effort data democratization in young teams. It optimizes as a senior, jump the learning curve as a junior. Let me tell you briefly how DLT works. Basic DLT pipeline has 3 main steps. First, extract, normalize, and load. Extract means it fetches data from source system and write it to local disk as of JSON files or Parquet files or any other files. Next step is normalize. And during this step, DLT reads extracted data from local disk, infers schema, and transform data in memory. Transform data to local disk. And the last step is a load. During this step, DLT reads normalized data from local disk and ingests into destination system. That's why DLT is database agnostic. It means the load step is a separate step, and only on this step is we have any difference during data injection. So that's pretty much about introduction. And let me check a little your questions. Okay, Huber will care about them, and we'll continue. Let's start with DLT Hub. In this tutorial, you will learn how to run a pipeline, store data, explore the loaded data. So let's get started. Data pipelines can be created between sources and destinations. Sources, it's locations from which data can be pulled. It could be APIs, databases, files, anything that can take the form of a list of dictionaries. Destinations are locations where DLT creates and maintains a schema and loads your data. Destinations come in various forms. It could be databases, data lakes, vector stores, or files. We maintain a set of verified sources.
When the slides are on.
Oh, don't see the presentation. Okay. Can you see that? I can see it.
I think it works now.
Okay, good. Yeah, again, data pipelines can be created between sources and destinations. We also maintain a set of verified sources and built-in destinations. That's just some of them, not all of them, of course, and we will talk about them a bit later. For this tutorial, we will use some toy data and later explore other data source options. So let's get started. It's super easy to install because DLT is just a library. We're using pip install. I'm not gonna run all these cells because it takes time and we have only 2 hours and a lot of information. So install DLT with pip. In this example, we're gonna use DuckDB as a destination. So it means we need to install DuckDB as extension. You can install it separately, like pip install DuckDB, or you can install DLT with DuckDB as an extension. Here, we define our toy data as a list of dates and trying to load them into DuckDB database. First, we define our pipeline, our DLT pipeline. It has arguments like pipeline name, destination, or dataset name, or schema name, and some extra arguments like dev mode. I recommend to use it for prototyping. When it's set to true, every time you run this pipeline, a new schema will be created in the destination database with a datetime-based suffix. When we define the pipeline, we can run with data. Our data is just a list of dates now. When we run data as a no-name list of dates, we have to set table name, so it's mandatory. Run the pipeline and see the output. Okay, so pipeline was completed. Load step was completed in 1 second for 44 milliseconds. As we remember, we have 3 steps. We have extract step, normalize step, and load step. This load info is only about load step. We can see the path to your DuckDB dump. You can see your dataset name and number of your load package. So you can use it later when you explore your pipeline. So let's explore this data with our Streamlit application. We need to first install because it's not included in DLT package, of course. And with the easy command DLT pipeline name show command, we run the application. I'm not going to run it right now, but you can try it at home yourself. And the result looks like a Streamlit application with the table schema. You can see the data. You can query this data. So your data was loaded. Also, we have another option. We can explore your loaded data with SQL client. It's a built-in SQL client, which is just a method of pipeline object. So we're just taking our pipeline object from the previous tab and starts our connection to your SQL database. Then we execute the query. This could be any query you need. We use table name users. Yeah, we set the name in our pipeline run. And fetch it all. And we got our loaded data. So we also can retrieve our data as a pandas data frame. We just use method. Instead of fetch all, we can use it df. And the result is just a pandas data frame. In this example, we checked how many users we have. Just 2. So that's it about getting started. And now we go deeper. Let's explore a little our pre-built sources and destinations. Our verified sources are the simplest way to get started with building your stack. Choose from any of our fully customizable 30+ pre-built sources, such as an SQL database, Google Sheets, Salesforce, and others. And with our numerous destinations, you can load data to a local database, warehouse, or data lake. Also choose from Snowflake, Databricks, and more. or build your custom plugin. Of course, it's an option. Let's try our verified source. First, we can check what verified sources we have with the command DLT init list verified sources. Here we can see we have Personio, we have Jira, HubSpot, Airtable, Notion, and many more. This command shows all available verified sources and their short descriptions. For each source, check if your local DLT version requires update and prints the relevant warning. Let's consider an example of a pipeline for Pokemon API. This command will initialize the pipeline example with Pokemon as the source and DuckDB as a destination. So there's an output. You can see that DLT just cloning our external repository with all verified sources and copy verified source code to your project. Now we can just run. Now we can just run Python command with the Pokemon pipeline script, and voila, all our data is loaded. A little about built-in destinations. We have a lot of built-in destinations like Google BigQuery, Databricks, DuckDB, ClickHouse, Postgres, Keydrant, Metadata, and you can switch them easily. For example, we ran this command DLT init Pokemon into DuckDB. Now we can easily change it to Metadata or BigQuery. Also, same if you declare your pipeline yourself via Python, you can change it in DLT pipeline. That's it. That's what you only need. And small spoiler, you can write your own custom sources, custom destinations. DLT Hub team trying to simplify as much as possible both process of creating sources and custom destinations. We will look at this topic in more detail in the second part of the workshop. Go further. I want to introduce you the resources and sources terms. What does it mean in DLT world? As we know, ETL pipelines means that you load your data from source to destination, and the source could be any API like payment service, or its database, or its Notion page, or Airtable, Google Sheet. It could be even CSV file or Pandas data frame. So let's first look at the simplest way to load data into a database using DLT. First, we need to install DLT, and let's try to load Pandas data frame into DuckDB. You can just directly provide your data frame into pipeline run, set table name, and run the pipeline, and it's gonna work. Or you can directly move your data from database into another database, like from MySQL to DuckDB using SQL Alchemy. We just create engine, query data, getting rows, define pipeline, and run pipeline. Yeah, first we need to map our data with column names. So also we can get our data from API and load it to DuckDB in a few lines of code as well. We for this purpose, we're using requests library. And we request URL, for example, github.com. We're trying to get all issues from our DLT repository and move it to DuckDB. So that's it. Set table names, our data in in the list of JSON format, and run it. It was the easiest way to load your data, but our real life, it's not so easy, and usually we need to build more difficult sources. So DLT comes up with a way for you to manage the data flowing into your pipeline using resources and sources. In the context of the DLT library, source, it's a logical grouping of resources, typically representing endpoints of a single API or tables in database. It is a function decorated with DLT source that returns one or more sources. Sources are useful for defining schemas with tables, columns, performance hints, and more. They also contain the authentication and pagination code for a particular API, making them essential for data extraction and transformation. A resource, on the other hand, is a logical grouping of data within a data source, typically holding data of similar structure or origin. For example, if the source is an API, then a resource is an endpoint of that API. Resources are useful as they represent the actual data that is extracted from the source location. Here's a small diagram. You can see that source on top of hierarchy, and resources, it's a subset of our data. It could be endpoints or tables or any other logic you want. Let's start with the resources. I just took the same code as I used earlier and wrapped it with DLT resource decorator. As you can notice, I set table name in resource decorator, not in the pipeline run. And also I yield data from the function. So yeah, this code creates DLT resource, which we can directly provide into pipeline run. So that's it, your data is loaded. And DLT resource decorator takes a bunch of arguments that helps you control the schema of your data. I will tell you about it a little bit later. Let's check out loaded data. You can see that DLT unnested the data and created child tables. That's a main table. That's a child tables. Also, you can notice that the special tables are created. They are created to track the pipeline state. These tables are prefixed always with DLT. You can read more about destination tables later. So let's check out the tables we created. Let's look into issues. There is all our data we retrieved from API, and additionally, DLT creates special columns. You can see them because we have like 100 columns, but believe me, there are new columns like DLT load ID. It's a unique identifier for each load package. Also, there is a DLT ID, which is a unique identifier for each row of all data tables created by DLT. Okay, also you could ask yourself, or maybe Hiba and Anun in our chat, why do we yield and not return our data in the DLT resource function? Let me remind you what's the difference between yield and return. Return is used to exit a function and send a value back to the caller after computing a result. And yield turns a function into a generator, which can send a sequence of values back to the caller one at a time. It means that instead of generating all the values at once and storing them in memory, so it could be a huge data set in a million rows, so it generates them one at a time. Now I want to introduce you transformers. You probably think that now I want to transform our data as a DBT models or something, but no. We use DLT transformers to feed the data of one resource into another. For example, you can use one resource to retrieve a list of repositories and another that retrieves the issues of those repositories. Let's do that. We created DLT resources, which retrieves all repositories of DLT Hub organization. And we created another resource. We call it GitHub Issues. As you remember previously, we retrieved all issues for a particular repository. It was DLT, but now we want to retrieve all issues for all repositories of DLT Hub. So this function returns the list of JSONs with all repositories. And we provide this data from this resource to another with that data from. And iterating item by item, because we remember that we yield a list of JSONs. And we iterate them item by item and request all issues for a particular repo. And again, we yield the data. So we just put DLT issues resource into pipeline run and run it. Let's look on our tables. As you can see, DLT again created the data of, oh my God. DLT again created special tables where it tracks pipeline state, and also it creates issues. Tables for issues. But as you can see, only issues were loaded without repos. So we have two resources. We provide them only one, which depends on previous one, on the DLT Hub repos or GitHub repos. But loaded were only issues. So let's figure out why. Well, let me try. Now we will try to combine all our sources as a one source. Just imagine we have first resource, it's all our DLT Hub repositories, and the second resource, it's all issues from all repositories of DLT. We can have many more resources. You can have pull requests or GitHub reactions or comments. And now we can do pipeline run for each resource to have all of them loaded, or we can group them into one single source and run the pipeline just one. Introducing sources to group the GitHub resources. We use DLT source decorator to turn the function into sources and return our resources, DLT Hub repos and DLT Hub issues. What did we do there, you ask? We used DLT source. So we just grouped all our endpoints in one place. Why we do that? This is more efficient than running your sources separately. it organizes your schema as well as your code. Let's run the pipeline with this source and look what we get. Again, define pipeline as a DLT pipeline, set pipeline name, destination, dataset name, optionally set dev mode, and run the pipeline with GitHub source. And we can see that okay, you can see it because it's not here. So now it should be GitHub repos and issues be loaded. Oh, it's not here. Okay. Also, you can control your sources and resources. And these decorators are quite powerful. For example, DLT source decorator has many arguments like name. It's the name of the source, which is also the name of the associated schema. We can control our nesting level with max table nesting, a schema hint that sets the maximum depth of nested table above which is the remaining nodes are loaded as struct or JSON. We can set root K. It's important for merging. We can set schema explicitly. Yeah, if not, if schema not present, DLT creates new schema. Let's look into resource arguments. It's almost the same. Also, it's a name of resource. It's a table name. It's a max table nesting. Also, you can control your write disposition. So it controls how to write data to your table. We have different modes like append, replace, and merge. We have, you can change your column types with the list, dict, or pedatic model. For example, you just set columns as a, if you want to change just one column data type, you should provide the column name and what data type you want to set. It also they have sources and resources. They have other arguments, but they are for more advanced course. Instead of providing arguments, you can use hints. Apply hints creates or modifies existing table schema by setting provided hints. For example, we set table name repos, defined resource, but then we decided to change the table name. And we can apply hints to the function and set new name. Or if you're working with sources, you can you can apply hints for resources in source this way. And you can see you have issues, it's an old name, then we changed once, then change it twice. So that's it for sources and resources and how we can declare them in DLT. Let's go further. Okay, now I want to talk about configuration. It's important because usually you creating sources or setting destinations and they have credentials. And it's quite an important part of the whole ETL workflow, how to handle credentials. DLT gives you two ways. you can set credentials with TOML files or using environment variables, or actually you can do it via Python in code. Let's take an example from the previous tab, but I a little bit upgraded it with pagination. So our example is getting more serious. And the primary rate limit for our unauthenticated requests is 60 requests per hour. Sooner or later, you will face rate limit errors. And now we can authenticate ourselves with access token. So now it works, yeah, now it's good. But if you run it oftener, you can have problems. And if we authenticate ourselves with access token, it will increase the rate to 5,000 requests per hour. Let's start with setting credentials with TOML files. We set up first DLT folder. If you run verified source with the DLT init command, it will create automatically. It will be created automatically. But now we're working with our custom source, so we need to create DLT folder ourselves. So we check that DLT folder doesn't exist. Then we create this folder. Now we have it. And move our credential into secrets TOML. I could do that via editing the file directly, but Colab notebook doesn't let me do that. So that's why we need to use command line. Yeah, we moved our credentials into secrets file, and it's here, as we can see. Further, DLT automatically check this folder and take in the credential values. You can check it with the DLT secrets. And you can see, yeah, it's here. So our value is also access token. Further, we're gonna use DLT secrets value. It's special object which inject your credential values directly into a variable in your resource or source object. To use DLT secrets value, we need to set it for arguments, like this. Also, you can skip defining it in source. I can define it only in resource. For example, it's going to work even this way. So now we don't need to do anything. We just put our secrets in TOML file, set DLT secrets value for arguments as a value, and run the pipeline. It's not going to work because we set a fake access token, so that was expected. So the second method is environment variables. It's useful, especially when you work with Airflow or GCP and you have no chance to use TOML files. So you can just set your environment variables like access token. Google Colab has his own secrets vault. You can see I set it here, so I can read it from Google Colab secrets and set it for access token variable via Python. In this example, we set access token directly in resource, but we can also do it like this, and it's going to work as well. Another way, without using OS getenv, when we set DLT secrets access token explicitly via code, never provide your credentials like this, because you can accidentally commit it and share it in public, all your secrets. It's better to store your credentials as a environment variables or in configuration files. Here we also use DLT secrets value as a default value for access token argument. So in these examples, I set access token just as access token. And for example, if you have another source and you have a credential with the same name and you want to separate them by sources, you can use configuration sections. For example, we can set in TOMO file like sources, GitHub sources. It's a default name where DLT looks for sources credentials. GitHub source, it's our source name, this one. And we can have a list of credentials. Also, you can do the same via environment variable. First, you also use sources, the keyword, then you use source name and your secret. And you can see that you should use double quote. Okay, you can use the symbol twice. And or also you can do it via Python. For example, if your credential changing during the time, for example, if a refresh token or I don't know, if you want to change your secrets dynamically for some reason, you can use it via Python. You just rewrite it with the DLT secrets. Here you should provide the same sections and secret. And here you can set the value from environment variable or from the Python variable or, I don't know, cloud secret provider. Here is a little bit about hierarchy. For example, environment variables is always rewrites any other values. For example, if you set credentials in secret TOMO file, and then you set environment variables on top, environment variables will overwrite the secrets TOMO file. And that's it about configuration. Let's go further. Okay. Let's explore schema. So I took the same example from the previous part and we run this pipeline. So we remember that we set our credentials as an environment variable. We have pagination as advanced users. We set DLT resource and source. Run it. Yeah, everything is good. Now we have well-working pipeline. It loaded your data, and now we want to know how, what happened. Data was loaded without fails, luckily, and let's take a look behind the curtains. A small reminder from the presentation how DLT works. As we remember that DLT first extracts your data to the files on the local disk, and then it normalizes it. During this normalization step, DLT infers schema. So the schema describes the structure of normalized data. For example, tables, columns, data types, and provides instructions on how the data should be processed and loaded. That's why, actually, if you have no data in your tables, DLT won't create the table because it has no data, and DLT doesn't know what the schema is, what columns, what data types. And you can provide your schema explicitly if you know it. Then DLT generates schemas from the data during the normalization process, right? And user can affect the standard behavior by providing hints that change how tables, columns, and other metadata is generated and how the data is loaded. As you remember from the sources and resources part, such hints can be passed in the code to DLT resource decorator or pipeline run method or via apply hints function. Schema can be also exported and imported as files, which can be directly modified. DLT associated a schema with the source and a table schema with the source. Let's inspect schema. When you create and then run a pipeline, you may want to manually inspect and change the schema that DLT generated for you. Here's how to do it. First, we can look into schema with CLI command, DLT pipeline, then we use DLT pipeline name and command load package. Here you can see all information about loaded data, pipeline name, package number, the location, and details about jobs, and of course the last schema update. Also, we can explore our schema with Python. Do you remember when we run pipeline, we have artifact load info, and this load info is quite powerful. We can look into load packages using this load info, and this load packages have a schema method. And let's look what the schema is also an object, and we want to know what other methods and attributes the schema has. Oh, there are a lot of them. You can know everything about your schema. But now I'm interested in this method, to print a JSON. We want to print our schema as a JSON. Here we are. There are some important parts of the schema, like a number of version, a hash of version, name of our schema, and all information about tables. Here we can see that the tables, their columns, and data types of columns. For example, our issues table, it has column URL, which has data type text, has user ID, which data types is big int, and so on. And another interesting part, it's settings. We keep all settings in our schema. For example, detections. It means that DLT will trying to guess if your big ints are timestamps. Well, let's talk a little bit about schema, hash, and version. Each schema file contains content-based hash, version hash. That is used to detect manual changes to schema. For example, if user edits content of the schema file, or detect if the destination database schema is synchronized with the file schema. Yeah, small reminder or just new information that we store our state as schema in the both places locally on the machine and in the destination. And sometimes we sync them. So each time the schema is saved, the version hash is updated. Each schema contains a numeric version which increases automatically whenever schema is updated and saved. This one. So let's skip it and talk about data types. There are DLT data types. DLT supports text type, double, bool, timestamp, data, time, big int, binary, complex, decimal, and array. You can change data types with Python. For example, when you set your resource, you can pick columns you want to change the type. For example, it's some column is name tags. And we know that this column contains JSONs or lists, and we don't want them to be unpacked. And we can set complex type, and DLT will store it as a string. Also, you can do the same with apply hints. Just provide the columns and data type you want, and it's going to be applied. But also, there's a note that DLT doesn't change your schema if it's already was created. So you first need to delete all your previous runs, previous tables in database, and run it again. So DLT never changing your schema in a destructive way. So you need to run it again. A little about schema settings. So let's talk about data type auto detectors. By default, DLT checking also checking only timestamps, but also we can ask it ISO timestamp, but also we can ask it check dates, large integer, hex bytes to text, and weight double. Also, we can define global rules that will apply hints of newly inferred columns. For example, if all DLT parents ID columns are foreign keys by default, you can add new columns you want to being foreign keys by default for your future runs. Or yeah, you can set which one should be null, which one should be unique, or being a root key. And you can define rules that will set the data type for newly created columns. For example, if you have new column and it contains timestamp in the name, you can set the template and ask DLT to track these columns and convert them into timestamp data type. You can not only explore your schema, but also you can modify it. You can modify it via Python. Also, you can modify it via schema file. First, to export your schema, as you know, DLT infers your schema on the first run, and you can export this schema as a file. For it, you need to just provide the path to the directory you want to store it, and you can change the Also, you can provide the import schema path. It's a folder where DLT will try to find the schema and use it instead of default one. So when we run this pipeline, the following folder structure in the project root folder will be created. Rather than providing the path in the DLT pipeline function, you can also set them in the config toml file. How importing a schema works. When a new pipeline is created and the source function is extracted for the first time, a new schema is added to pipeline. This schema is created out of global hints and resource hints present in the source extractor function. Then every such new schema will be saved to the import folder if it doesn't exist there already, and used as an initial version of all future pipeline runs. Once the schema is present in import folder, it is writable by the user only. Any changes to the schemas in that folder are detected and propagated to the pipeline automatically on the next run. It means that after a user update, the schema in import folder reverts all the automatic updates from the data. Repeat, caution. DLT will not modify tables after they are created. So if you have a YAML file and you change it, for example, change a data type or add a hint, then you need to delete the data set or set def mode equal true. Also, you can change your schema any way you want. So you can change data types, you can change settings, default hints. Here should be a real coding example, but it will take time to run it. Okay. Oh, let's do that. So the main idea that we take in the created schema file, open it, edit it, save it, and DLT automatically apply the changes. For example, if we want to change a column from big int to text, we just go to this file, change it, save it, and run pipeline again. Yeah, it's so long. Yeah, now we can see schemas folder. Export, it's a schema which were generated automatically by DLT. And in import folder, we have the same file right now, but now we can change it. For example, I don't know, changing ID to text type. Save it. And now DLT will take this changed schema from import folder And it was just changed. Yeah, but yeah, we can see it was changed. For example, we have change number to double and run it again. Mhm. It didn't change. Ah, I changed it in the expert file. Double and run it. Now it should be changed. Okay, it's not. Whatever. Okay, let's go further.
We have a break now. Do we have a break now?
Oh, it's already. Oh, wow. Yeah, let's have a small break because many of you need to go to the toilet or drink water. Maybe me. So meet you here at 5:20. At 5:20. Oh, will you ready? Let me check the questions.
Oh, we got the questions so fine. It's going very smoothly, by the way.
Huh?
It's going very smoothly. You're doing amazing.
Yeah. No. It's already 5:20. We can go further. I hope you are ready for interesting part of data pipelines, incremental loading. It's one of the best practices in ETL pipelines. And let's get started. Incremental loading is the act of everything is good. You can hear me, you can see it. Yeah, everything is good. Incremental loading is the act of loading only new or changed data and not old records that were already loaded. To understand different methods of data loading, let's look at the following walkthrough. Imagine a Notion database. Um, Here, a team manually adds rows every day. No one deletes anything, but new rows get added every day. So, what method will you use to add this data every day to a database destination? When you create a data pipeline, you have many ways to load this data into a destination. Methods of loading data to database. Here are some ways you can append your data one by one. You can replace it. Just take all your data and replace it with another. So, and you can merge by key. What can this look like? Here are some examples. How? Mm-mm. No, I can't insert. It doesn't work here. Okay. Yeah, it doesn't work. So we can see how works appending data on this very small picture. Um,
You would just do this on your
no.
That's
Or I start working. Sorry.
Yeah. And
For example, you had your data like incremental loading, custom destination, text, beginner, and advanced. And you appending new data with the rare disposition and configuration with text beginner. You just have 4 rows as a result. It's replacing data, it's more intuitive. You have like 2 rows of data, and if you change anything or you want to add new data instead of the old one, you just replace the whole data with the new one. And merging, it's the most complex and interesting right disposition. For example, we have 2 rows with different values, and we want to change this data and maybe add new data also. And we don't want to replace it, but we want to update it. Then we can merge this data, in this case by project name or by ID or by any other merging key. Yeah, that's pretty much about. If we go back to some case from the first Notion page we imagined, which method of adding data to a database would work best? You can answer it in chat, but there's already answer in the column. The answer is it's replace or merge. Append would lead us to have duplicates, but there's a nuance. If you have not changeable data, for example, events, when you every day you're having new data and you know that all data will never be changed, then in this case, append would be the best decision. So just add new data. Let's discuss rare dispositions in DLT. How DLT handles all these 3 methods. The methods we just saw in the previous example for loading data are known as right dispositions in DLT. These are set up with this resource decorator or pipeline runs, or apply hints. DLT has three main methods of reading data, as we discussed earlier. It's append, replace, and merge. Moreover, these are three strategies to merge right disposition. So you can merge your data with the delete insert strategy, SCD2 strategy, and absurd strategy. For this notebook, we will be using the default delete insert strategy. We're gonna take a toy example with the Hogwarts admissions department. And let's look at the basic example. We have been asked to set up a pipeline for the admissions department at Hogwarts School of Witchcraft and Wizardry. We're creating DLT source as we did before. We set function, we wrap it into DLT resource, we set resource name, we can set also table name. If we do not set it, features, DLT will take function name as a default table name, or a resource name. Yeah, in this case, we can skip table names because DLT will take resource name by default. Also, we can set primary key. It's for right disposition append. It's not necessary. It's just if you need it. And yield our data. So again, we declare the pipeline with pipeline name, destination. We can pick any we want, and dataset name. Let's run it. Okay. We want to add new students. For example, Harry Potter. Then more students showed up, and we decided to add 2 more students. And a few years later, Ginny joined Hogwarts as well, and we added one more record. So now we have the table with name creators and all our students in this table. So we just used append. We added rows one by one without changing all data. So it makes sense if we never change our data. Second right disposition is merge. Oops. Judy starts a year later with the new one. Here's how we can do that. We can change the configuration of our resource add students directly in pipeline run method. We're just setting primary key and changing right disposition from append to merge, and providing the data updated. So as primary key is name, we shouldn't change the name, but we can change other data like date of joining. We see Ginny's date started get updated. So we do not have duplicates. So if we kept right disposition as append, here would be 2 Ginnies with old data, date, and the new one. But we change it to merge. And now we escaped of this duplications. Let's see if the merge operation changed anything in the schema. We see the introduction of a new schema called Hogwarts Staging. Let's check the content. So as you should remember that on previous parts, when we ran pipelines and looked at tables, there were only one schema and the only tables of this schema. And when we changed our disposition to merge, we can see some duplicated schema with staging suffix. Let's look into this hover staging schema in creators table. We can see there is only one record. It's Ginny Weasley with the new updated data. We see that only the row we changed got added into the staging table. In this default merge strategy, delete insert, DLT loads data to a staging dataset, deduplicates the staging data if a primary key is provided, deletes the data from the destination using merge key or primary key, and then inserts the new records. All of this happens in a single atomic transaction for a parent and all child tables. The last right disposition is replace. Imagine that Gryffindor House haters steps in as the new data engineer and wants the destination database to only contain students from another house. He has a record of only Slytherin students and wants to add them instead. So we adding new students and changing right disposition to replace. Let's take a look at that database now. So we can see that all Gryffindor kids get erased, and now in the Gryffindor, only our Slytherin guys. Oh, that's a little bit sad. Let's remember our GitHub example from the previous tabs. It's a more real-life use case, and let's explore how we can ensure that no duplicates exist within our data table using DLT deduplication method. We creating pipeline. So yeah, the following code creates and runs a pipeline from the GitHub API point to the DuckDB destination, as in the previous examples. We're So, okay. We run it. Okay, it's loaded. We remember that it works. If we run steps 1 and 2 again, if we run the pipeline again and again, we can notice something, that our data will be duplicated. Like all our issues will be double on each run, because DLT uses append by default. Yeah. To get the latest data without duplicates, run the script below, which sets the right disposition to replace. Yeah, we running almost the same example. The only difference is that we provide right disposition to pipeline run method. Yeah, and now all data will be erased and insert again on each run. Now we want to learn how to make your pipeline more efficient. And let me introduce you incremental loading. So to load the data as it arrives, you can adjust the code above so that it now supports incremental loading. To do so, we should use the decorator resource, and which we can provide table name here and specify right disposition. Also, we need function get issues, which fetch and yields data page by page. Also, we need to track the created add field in this function to filter only new data. This field is tracked using DLT source incremental. What is this DLT source incremental? It is used to track a specific field in the data that indicates new or updated records. It is often a timestamp or sequence number, like a created add field. It keeps track of the last value of this field from the previous run and uses it to filter in the newly created or updated records in the current run. Let's look into the example. So now we have DLT resource with the right disposition replace. We move, setting created add as a DLT source incremental. We provide the field name inside of this function. So this the name of the variable could be any you want. Also, we provide initial value. It means that when we start using this created add variable on the first run, this variable will have this initial value. So now on each run, DLT will replace the data and so okay. If created add, yeah, now I can see it. Here, DLT stop requesting pages if the last element was already older than initial value. Incremental will skip those items anyway. We just do not want to use the API limits. So we're just trying to make the requests efficient, especially if you have limits, rate limits. So let's consider a situation where we need to update our data, not only add new one, but also we need to update some old data, which we already loaded before. So to keep the database updated with the latest content, including updates to existing records, you can combine incremental loading with the merge right disposition. So what changes we use? First, we change right disposition from replace to merge. We setting primary key. In our case, we know that DLT or that GitHub API returns ID for each record, and we can track our data by this ID. We change also our incremental variable from created add to updated add. So we're interested not only in new data, but also in new data and updated old data. Also, we can make our requests even more efficient. We can request only issues with since parameter. So this request will return only data which is not older than the last value of updated add. So, and using this since parameter, we avoid this construction. we can see that all data was loaded. So how does this work? Merge by disposition. It updates existing records based on the primary key. It track updated add field, filters issues updated since the last run. It also uses parameter since we're using updated add last value and pass it to the API to fetch only updated issues. Yeah, that's it about basics in incremental loading. And let's talk about more advanced incremental loading knowledge. Let's discuss merging right disposition. As I mentioned before, merging right disposition has three strategies. It's a delete insert, it's a SCD2, and just insert. Let's look at this diagram. It's too big. I can't make it smaller. Okay. When we building pipeline, we thinking which right disposition should you use? First, ask yourself if your data is stateful. If it's never changed, like advanced or logs or something, just use append. It's the best way to add your data. If your data is stateful, so it has some state and the state could be changed, you need to ask yourself, do you need to track history of changes? In the most cases, you don't need it. You just update your data, but sometimes, for example, data model holding stock prices, and we need to save current and old functionalities. And if we need the history, we use slowly changing dimension, SCD2. If we don't need a history, we just can ask ourselves, can you request it incrementally? If no, then we replace the whole data. If we can load it incrementally and we need to update our old loaded data, we use merge. Okay, let's talk about what is stateful data. Refers to data that has a state which can change over time. For example, stateful data, it's a user property on a website. User can change their profile picture. Stateless data, it's a page views on a website, can only be recorded once and not changed. Okay. Let's start with delete insert strategy definition. The delete insert strategy loads data to a staging dataset, as we remember from the previous part. It deduplicates the staging data if a primary key is provided and deletes the data from the destination using merge key and primary key, and then inserts the new records. All of this happens in a single item transaction for parent and all child tables. In this notebook, we will discuss other two strategies. It's absurd and SCD2. Absurd strategy. The absurd merge strategy does primary key-based absurds. It updates records if key exists in target table. And insert records if key doesn't exist in target table. You can delete records with a hard delete hint. To control your strategy, you need to provide, instead of right disposition merge, you need to provide it as a dict. Here we mention what disposition you use, merge, and strategy. And also primary key. What's the difference between upsert and delete insert? Delete insert needs a primary key. It expects this primary key to be unique. And it doesn't support merge key. Uses merge or update operation to process updates. Let's go to SCD2 strategy. DLT can create slowly changing dimension type 2 destination tables for dimensional tables that change in the source. The resource is expected to provide a full extract of the source table each run. A row hash is stored in DLT ID and used as surrogate key to identify source records that have been inserted, updated, or deleted. There is a short demo. We define our source as usual with the decorator. Also provide right disposition, merge, and pick another strategy, SCD2. Run the pipeline and look into the data. Now we have two schemas. It's our schema and staging schema. It is normalized for every column, and each generated table has a staging table. Let's see what the difference is so far. Okay. We can see that for parent table creatures, we have unique DLT ID. And creature's name is a child table which was created automatically by DLT. And see that DLT root ID is the same as DLT ID from a parent. And also you can see that DLT parent ID as a separate column and also have the same key. And what we have in the staging tables, you have it. Almost the same, but the difference is the date. Let's add the rest of the students, run the pipeline, and look at the table. Now we have 4 records, DLT valid from and valid to. Valid 2 has 1 null. It's our first student. It was Hari, and his valid from is this date, and it has no names for valid 2. Yeah, we can also see that creatures name table has all our names, our students' names, with the DLT parent ID from the parent table. Okay, staging table has only one. The last added, yeah, only the last added student. And okay, let's making the change. Let's update our Genie Weasley student with a new date of joining. We can see that our table, our main table has duplicates. So now we can see that Gene Weasley duplicated in here, but there is a small difference. Mhm, mhm, mhm. Yeah. In the main table, we can see that utility ID are corresponding to these two Ginny Weasley records, and one of them has valid 2, and another one doesn't have. It means that this this record is not active anymore. So we keep it in a history, but so we do not delete it, but we telling that this record is old one, and so it's not valid anymore. Yeah, and in a staging table, we have only new updated Ginny Weasley is new DLT parent ID. So now we're moving to metadata. Now we're trying to explore our pipeline even more. We're trying to know everything about loaded data, about all metadata we have in our pipeline. Okay, we have only 8 minutes, so try to be quick. Oh, metadata is basically data about data. So pipeline metadata is data about your data pipeline. This can be useful if you want to know things like when your pipeline first ran, when your pipeline last ran, information about your source or destination, processing time, or information that you yourself may want to add to the metadata, and much more. DLT allows you to be able to view all this metadata through various options. This notebook will walk you through those options, namely load info, trace, and state. Creating pipeline to view its metadata. Yeah, first we need to run pipeline. We took an example from our previous tabs. It's a serious source, it's a serious pipeline where we are getting issues from GitHub API incrementally with a merge write disposition and yeah, with the pagination. Run the pipeline, data is loaded. Let's look into data. Everything is perfect. And let me introduce load info. So you could notice that every time we run the pipeline, we're printing some load info things. And actually, it's a quite powerful DLT object. So in the package information, you can see the list of all tables and columns created at the destination during loading of that package. Let's inspect this load info. First, we can use CLI. I did something similar on the previous parts, as I remember on that. Yeah, we can see some basic information about our loaded data. We can see that there is a load ID. The load ID of a particular package is added to the top data tables and to special DLT loads table with the status of, no, it's not this. So this was slightly changed and I'm lost a little. So yeah, DLT tracks DLT loads. When you run your pipeline, each time you load your data, DLT increase the number of DLT load, just +1 in each time. But it happens only if the process is fully completed. If your load wasn't completed successfully, it won't be incremented. Um, okay. We can look into particular load package. We can take a load package ID and provide it to the command. That's going to be found. Oops. Okay, let's just.
Do you want to
Huh? What?
Do you want to open the one that is just state and not metadata? That's the one that is state.
Yeah, probably.
And you can take time.
Hmm?
You can take time here, so it's
Okay. Yeah, that's what we ran pipeline, looked into the data, and check load package. Yeah, that's the worked version of this collab. So yeah, we can use DLT pipeline load package command for particular load package, and let me introduce DLT state. The pipeline state is a Python dictionary which lives alongside your data. You can store values in it and on next pipeline run request them back. When to use pipeline state? DLT uses a state internally to implement last value incremental loading. So we're just saving our last value in a dictionary. Yeah, so our state is just a dictionary. And this use case should cover around 90% of your needs to use the pipeline state. Or you can also store a list of already requested entities if the list is not too much bigger than 100K elements. Also, you can store large dictionaries of last values if you are not able to implement it with the standard incremental construct. Or you can store the custom fields dictionaries, dynamic configurations, or other source scope state. And important information when not to use pipeline state. Do not use DLT state when it may grow to millions of elements. Do you plan to store modification timestamps of all of your millions of user records? This is probably a bad idea. In that case, you could store the state in Dynamo database or Redis, taking into the account that if the extract stage fails, you will end with invalid state. Use your loaded data as a state. DLT exposes the current pipeline via DLT current pipeline, from which you can obtain a SQL client and load the data of interest. In that case, try at least to process your user records in batches. So, surprise, you can save some additional information which you could save in state. You can just load it to your database back and track it. Let's inspect state. First, we can use CLI. For example, we run pipeline, and now we can use CLI to check the info about this pipeline. I used verbose key to get more information, for example, about sources. So the info command will show you main information like pipeline name, state version, dataset name, schema names, destination type, version hash, by the way, Where's the hash of schema? Yeah, what version of schema was run? Also, all information about sources. So it's kind of our state actually. That's how it looks like under the hood. When we run pipeline incrementally, we're just saving our initial value, last value as a dict. Also, we can see how many tables were loaded. Like we can see that main table issues was loaded with 140 columns. Also, you can see that it was unpacked and labels, assignees, and events were moved to child tables. Well, it looks very useful in my opinion. Go to second method. We can explore our state through Python. I prepared small function which reads state from a file. As you remember, I told you that we keep our state nearby the data, and also we keep our state in the local machine. So we have two places where we store it, and when we run pipeline, we always sync our state from destination and replace our local state. So now we can just open this JSON file and look into the state. It looks like this. We have all information about state, version. We have information if it was first run or not, because actually when you run it at least once, it always will be false. So it's true only if you never run the pipeline. Yeah, also you can see basic information about pipeline and sources. So it's almost the same as in the CLI info comment. And let's try to modify our state. We can change it on the resource level. Also, we can change it on the source level. Let's start with the resource level. For example, when we building a resource, we need to store some extra information in our state. Then we can use delete current resource state method and get all information we need. As you remember, the state is just a dictionary. So I just trying to get incremental key, updated it, last value. So now I have our last value. Or we can store some custom information in this state. If we run current state set default, we will create new key in our dictionary with the next values. So now we can see that new key was appeared on the resource level. You can recall it on the next run. Yeah, you can use it for anything you want. Let's consider what I've done here. New key, second new key. Yeah, that's a small example how we can reuse our custom information from the state. For example, on the previous, yeah, how we can update it, for example, yeah. We set new key as a list of few values, and if something happened, oh my god, we can add new key or do anything. Then we can get our incremental state and update it with a new value. So it's gonna look like, so incremental will be updated. We have updated add key and second new key. And resource keys will be updated with the, we have incremental and new key right now. We can reduce it later as we want. Also, we can do the same on the source level. And this state can be shared across resources. And it's also available read-only in the source decorated functions. The most common use case for the source scope state is to store mapping of custom fields to their displayable names. You can take a look at our pipe drive source of an example of state based across resources. I will provide link to this pipe drive source later. Okay. Yeah, so the process is almost the same. The only difference that instead of resource state, we use source state. Yeah, everything is the same. And as a result, we have resources. We have our resource, GitHub issue merge, and this, and this resource will have extra keys, extra values. Also, we can sync state with destination. It's all yeah. What if you run your pipeline on, for example, Airflow, where every task gets a clean file system and pipeline working directory is always deleted? DLT loads your state into the destination together with all other data, and when faced with a clean start, it will try to restore state from the destination. The remote state is identified by pipeline name, the destination location, and destination dataset. To reuse the same state, use the same pipeline name and destination. The state is stored in the DLT pipeline state table. It's one of our special tables which were created automatically by DLT. And it contains information about the pipeline run, and state block. DLT also has DLT pipeline sync command, where you can request the state back from the table. If you can keep the pipeline working directory across the runs, for example, if your machine will never removed, you can disable the state sync by setting restore from destination false. Whew. Oh yeah, let's look into this DLT pipeline state table. As you remember, this table created automatically for every DLT pipeline, and we can look into it. What we can see. We can see the version of the state, because each run state updating, the pipeline name, and this weird number of symbols. It's our state. It's actually just a content-based hash. So if our state changed, the hash will be changed as well. So column state is compressed to its own dictionary, actually. Yeah. Yeah, you can sync your state with the destination, and yeah, that's not interesting. Also, you can reset the pipeline state with the DLT pipeline drop and resource name. Pipeline drop command, it doesn't drop your pipeline and everything as everybody thinks, and I thought also. Now I know that drop command only reset the pipeline state, this dictionary. So that's what only what it does. Let's go to the trace. Let's run the pipeline and inspect trace with the CLI. Here you can see the information about all 3 steps. First step, it's extracting. Next step is normalization. And the last step, it's load. We can see the short information about all the steps. We can see how much time it took each step and try to, when we, for example, trying to improve performance for each step, we can track this trace to understand if we succeed with the performance or not. What else? Normalized steps showing you how much rows were loaded, were normalized, okay? And the load step, it's our usual load info print. That's what we see every time we printing load info after pipeline run method. With Python, we can see the same information with pipeline last trace. It's showing you just the same. You can reuse this information somehow if you want. For example, last trace, it's not only the text, yeah, it's object, it's still the object, it's like the load info. And we can use last trace additional methods and attributes to explore it even better. For example, we can check last extract info or last normalized info, or we can get row counts. Also, we can see our last load info if we want. So you can access all this information in your pipeline script. Wait, what happened? Oh, what happened?
There's some part missing from this.
Oh, okay. No. Just something happened. It was erased. Okay. You can access all this information in your pipeline script, save load info and trace to the destination. For each load, you can test and alert on anomalies. For example, you got no data or too much loaded to a table. You can save complete lineage info for a particular load ID, including a list of loaded files, error messages, if any, elapsed times, schema changes. This can be helpful, for example, when troubleshooting problems. Let's check what methods has load packages. In the beginning of this workshop, I showed you how we explored load packages schema. Yeah, it's here. But also load packages has other methods and attributes you can request and play with it. So that's it, actually. That's it. And thank you for your attention. If you have any questions, you can ask them in our Slack channel, because I think this chat in YouTube won't be active much after workshop ends. So join our Slack, subscribe our YouTube channel, and join our next workshops. Ciao.